Welcome back to A350 Checkride, and thanks for joining me. Today, we're stepping into the Airbus A350 ventilation system, one of those systems that seems sprawling at first glance. Cockpit, cabin, crew rest, cargo compartments, avionics bays, equipment racks, pack bays. Every occupied and operational space has dedicated airflow logic. But once you understand how the aircraft groups those spaces and who is responsible for monitoring them, it becomes a beautifully organised system. At the centre of everything is the ventilation control system. Two identical ventilation controllers, known as H41 and H42, run the entire architecture. Only one controller operates at a time, the other stands by fully ready to take over. If the active system fails, the standby quietly assumes control, and ventilation continues without pilot intervention, redundancy from the very first line. Those controllers don't collect data directly from the sensors. All of the analog and discrete sensor inputs, temperatures, airflow states, fan status, valve positions, are fed first through CPI-OMS. These modules convert raw signals into digital form and send them over the avionics network, making them usable by the ventilation system. And because Airbus never leaves a failure pathway untreated, the CPI-OMS also provide backup hardwired outputs to specific systems should the network or processors become unavailable. Moving forward to the flight deck, cockpit ventilation normally runs automatically, driven by the mixer output in conjunction with the pack system. The aircraft determines airflow and direction to deliver clear windows and suitable comfort across all flight phases. But manual authority is always available. The flight crew can force airflow to increase windshield defog, target lateral window clearing, supply fresh air to individual vents, and even adjust flow onto their feet around the rudder pedals. A push button on the air panel immediately forces windshield defogging, lateral vent defog selectors give each pilot control of their side window, and an electrical heater switch adds warmth where required. Behind the cockpit, cabin air is continually recirculated. 4 large recirculation fans draw air from the cabin and route it back to the mixer unit, where it blends with conditioned pack air. Effortless for the crew, but huge in terms of efficiency and passenger comfort. Not all air is retained. Lavatories, galleys, and high odour zones are ventilated separately. Their extracted air is discharged overboard rather than mixed back into the cabin supply. On the ground, or whenever differential pressure is low, an extraction fan operates and an isolation valve stays closed, sending air out via the outflow valve. In flight, when cabin pressure is high, the extraction fan stops, the isolation valve opens, and pressure itself pushes air overboard through skin outlets. And when ditching is selected, the system protects the hull. Relevant valves close to prevent water entry. Cargo ventilation breaks into 3 distinct philosophies. The aft cargo compartment receives conditioned supply air through inlet valves and uses an extraction fan to pull air overboard. Bulk cargo takes a simpler approach, using a commercial equipment extraction fan to remove a portion of cabin air. The forward cargo compartment mirrors the passenger cabin, receiving conditioned air with its own temperature control logic. All 3 spaces can be automatically or manually isolated in response to smoke. Isolation valves for aft, bulk, and forward cargo are available to the crew on the air conditioning control panels. Moving deeper into the aircraft, avionics ventilation follows a 2-channel architecture, a left circuit and a right circuit, each cool cockpit electronic panels in the avionics bay using recycled cabin air. Fans pull air through filters and distribute it across racks and equipment. If a fan fails or a filter becomes clogged, a backup valve opens automatically, drawing conditioned air from the mixer to keep avionics cool. 2 extraction fans then pull that warmed air out of the avionics bay and discharge it overboard. In abnormal conditions, the airflow can be routed via an inboard path instead. The VCS monitors these functions continuously and posts alerts to ECAM, ensuring crews always know when intervention is needed. Manual override remains an option. In flight, the flight crew may select AVNCS extract to OVRD, partially opening the overboard valve and forcing dual extraction paths. Fans continue running and airflow increases until the system stabilizes. And again, ditching overrides everything. If ditching mode is selected, the overboard valve closes regardless of the override position. Commercial equipment and pack bay ventilation close the loop. The IFE racks, crew rest extraction paths, and components supporting the cargo compartments have their own ventilation channels to supplement the cabin and avionics systems. Pack bays use ram air in flight, drawn in through dedicated belly inlets. On the ground, when ram air isn't available, pneumatic fans driven from bleed air cool the bay spaces and vent air into the bilge, critically keeping any smoke from recirculating into the cabin. When you stand back, three things define the A350 ventilation system. First, the automatic dual controller philosophy, H41 and H42, ensures the system never runs without a backup. Second, every compartment, from cockpit to cargo, has manual isolation or override options to contain smoke or enhance airflow when required. And third, avionics and pack bay cooling is layered with fans, valves, extraction paths, and ECAM support, giving the crew a clear pathway to manage failures. That brings us to the end of today's exploration of the ventilation system. In the next episode, we'll have a closer look at the A350 pressurization system. Until then, fly safe.